What I'm going to talk about here is in general the sanitary or hygienic product that we have, the industries that they're used in, the applications, a little bit of a product overview of the range, along with the features and benefits of each of those, mounting configurations, how to order, and some testing that has been conducted. The industries that this product serves include, but certainly fall outside of this as well, because we're finding more and more industrial applications for these hangers and tube supports. Primarily, it's pharmaceutical and biotechnology, at least for the rounded series, but certainly there's food, beverage, dairy, and personal care product industries that we also see our product in. Primarily on the applications is a hygienic process piping, such as in the clean room area, batching and production, and then as well, outside of that hygienic, we have utility piping, conduit, and other, well, so-called dirty area of manufacturing. But we do see an expanding range of applications, and we're learning about those and expanding upon those as time goes on. What I'm going to cover here as far as the sanitary product, there's essentially the four ranges of products here. We have the smooth bore series, which we have in the top right corner, the block style, some people like to call that. We have our RH, or rounded hygienic series. And then we're just in the process of introducing our CH compact hygienic series. Picture of that is in the center in the bottom there, which we'll get into later, and the differences between the RH and the CH. And finally, we have our fabrications, which include stanchions and pipe racks. And these are all support accessories to help on the installation process for any and all of our tube supports. We'll start off with the smooth bore series. Our support system typically is an efficient and economic method for hanging hygienic tube and pipe, supporting it, clamping it. A lot of different terms are used, but it's a fairly efficient system, and the range that it currently has for the smooth bore series is a 1/4 inch tube size to 8 inch pipe size. The reason why we call it smooth bore is simply because the inside bore of the pipe clamp itself is smooth, whereas typically on the industrial side, those are designed with ribs, and there's a certain feature and benefit for those ribs. As an industrial application typically has more pressure, possibly more vibration, and there's some benefits to having that rib design. But the smooth bore design allows it to be tight fit, doesn't allow any of the cleaning fluid or if there's any process fluid on the external part of the piping. It won't migrate into the bore and get caught up and harbor some bacteria and cause any hygienic problems down the road. Also, the fact that we have a plastic insert that's sandwiched in between metal hardware allows cushioning and dampening for vibration. That's also a nice design feature as well. And again, I mentioned the size, 1/4 inch tube size through 8 inch pipe. Standard hardware on the smooth bore is 304 stainless. We can also do 316L, and as well as zinc plated carbon steel, and most of those are for an industrial application, but those are the most economical. Our inserts are polypropylene material or a Sanitary material typically. In addition to that, for 8 inch sizes, we have a high temp nylon, and with those, as I mentioned earlier, we have several mounting configurations, which we'll get into. Polypropylene material, which is the cheaper of the two, or most cost-effective of the two. It's designed up to 194 degrees. It's a blue color with a brief exposure to 215 degrees Fahrenheit. And the Sanitary material, which is a beige color material, it's designed to 275 degrees Fahrenheit, 302 brief exposure. The Sanitary seems to be a very widely accepted material. A lot of other components out there made of Sanitary material that is commonly accepted in the hygienic process. The 6-inch through 8-inch pipe sizes, we have a high-density polyethylene, which is designed at 175 Fahrenheit, and we also have a Vecton material, which goes further up to 260 degrees Fahrenheit with brief exposure to 350. Here's a picture of, when we refer to the sizes of virtually all of our product line, we have it by grouping. So this would be the frame, which sandwiches the insert, and that would hold true for both the smooth bore as well as the rounded series. As you can see, this stacked unit has 3 separate sizes on the top, group 3. Then we have a group 6 in the middle, and group 7 in the bottom. As you see, those groups house a range of inserts, so essentially that whole can have a range of size that fits within that frame. Just want to give you a quick visual on that. The mounting configurations, on the smooth bore series, we have a few options here that are very, I guess universally accepted in industrial. Outside of these weld mounted, we have a ceiling mount with a hang plate. But what I was mentioning, as far as the industrial, we have rail and strut, so we can do a rail mounted, also stacking assemblies. So there's a lot of configurations and options to create more of a pipe rack scenario where you can house a bundle of pipes all in parallel. This particular graphic, shows the depiction of what that looks like in the field. As you can see on the top, there's hang mounts. Then we have side mount as well as a floor and a weld mount on the bottom. So really, it's up to the designer or installer to determine the best location for that, but we have several options to support those. This here shows the weld-mounted version. So as you can see, we've got a STW, which is a standard weld plate, and a cover plate, COP. This is the standard baseline unit for our smooth bore. And simply you would tack or weld the weld plate onto your support structure and then build the rest of the unit up from there, and it's very simple, very few pieces. All it is 2 inserts, a cover plate, and 2 bolts. So it's fairly quick and simple to install. And again, the most commonly used. The weld plate itself, as you see in there, you've got an 1/8-inch all-around weld recommended in the clean areas, and a tack weld in non-clean areas. This next one here shows the ceiling mount. So you can see that CMP, ceiling mount plate, for bolting into a support structure from the ceiling. And we have the HAP, which is hang plate, which allows you to have some flexibility on orienting that in the right direction. The bolt-mounted option simply takes that base plate and has extensions for bolt holes that are put in there, and allows you to simply bolt rather than to weld. The next few here show our strut and rail mounting options. This particular is the rail, which allows you to gang up several units all in tandem, side by side, which is, again, more efficient use of space. And there's a simple rail clamping nut that's used to lock those on, as well as you can use a rail nut. You can use the standard weld plate and slide that in between in between the rail and the insert. Either option will work for you. The one thing to note on here is not suitable for use in clean rooms. Obviously, with the rail itself and the design, there's a lot of crevices in there. So this is more from an industrial type of an application, but very commonly used. When you use that rail, you have a locking nut option on there, which is available just to keep the housings in place, and they won't slide around, even though you may have it bolted down. There is some torque, certainly, and as you have some pressures and vibrations in the line, you need to lock it. The stacking assemblies simply takes the standard units and provides the safety plate, additional stacking bolts, which allows you to extend that bolt one on top of the other and make essentially one extended bolt. So that essentially you would get the lower half of the clamp half, the safety plate, the stacking bolt, the top half of the lower unit, and that allow you to stack. And you can stack these up to 4 and 5 in height. So that's quite efficient use of space and very cost effective. As you can see, on the next one shows a visual of what that might look like. This one has a ceiling mount plate, a hang plate, and then also towards the bottom you see that SWV, which is a swivel plate, allows you to change direction. So again, you can take from one single point from the ceiling, have several lines moving in different directions, and all supported with under one location. This is what it might look like out in the field. This is an example. As you can see, there's 8 different lines, all supported under the same stacking unit. Also, we show stacking with different size groups. So there's a transfer plate that's in the center, which allows to mount the smaller size group. It always goes in descending order, so that the largest group is mounted to the base plate, and it can escalate on top of that and stack, but if the groups have to be equal or smaller in size. The other thing to point out here is an option with pipe supports, especially in the high temp or steam areas where there might be steam going through the process line. You have to allow for thermal expansion. So both the smooth bore as well as the rounded series offer what we call guides, and allows that pipe to essentially slide through. For the smooth bore series, we have a black Sanitary insert. All it is essentially a shim that's inserted into the body to give you about a 22 thousandths, or give or take, enough room for that pipe to slide through and allow expansion. That's a 1/16 of an inch for the block series. That's 22 thousandths on the rounded, which we'll show a little later. Getting into the rounded series, our RH product line. This is a graphic of what that looks like. And again, I'm going to go into this to also explain our compact hygienic series, as it's very similar, the same design features between the RH and the CH. CH will be launched hopefully within the month, and hopefully what that'll allow people is to have a a cost-effective alternative. Also, it adds some features for ease of installation as well. For the RH, it was designed specifically for pharmaceutical and biotech, where there's scenarios where it has to be highly hygienic, sanitizable, offers drainability, everything that is a requirement within ASME BPE standards. So again, it has to be easily sanitized and facilitate drainability. The other nice feature that both the RH and the CH have is it fits within the 1-inch insulation for a streamlined look, and also a continuous insulation, whereas on the block series, typically the insulation would be terminated on either up to the point where you would have the block, and then initiated after that, and then there would be a gap where there would be the support, so a gap of insulation. So this allows you to have the insulation butt up and be covered completely through the whole pipeline. The design, the patent that we have essentially is, allows slope adjustment via the special oval shoulder bolts hole. So it allows a slope adjustment in one direction, and perpendicular to that, it limits any kind of movement. So this again allows, if you're in a horizontal position, it allows slope one direction, but restricts it to the other direction if there's any issues with the pipe weight itself. There's a simple graphic showing slope. This particular visual shows 3 of our dynamic housings with rod extensions going through stanchions. A hang mount stanchion, which we'll get into later as far as one of the fabrication options we have. But this is a very common design that you'll see out in facilities. Our compact hygienic, which I mentioned we're getting ready to launch, which everybody will see a notification of very soon, has the same rounded geometry as the RH, and I'm going to get into the CH in more detail, but it parallels virtually everything in the RH. More importantly, has a lower weight, slimmer design, i.e. why we're calling it a compact series. The weight typically in the group 1 through 5, which brings it up to 2-inch tube size, there's anywhere between a 30 and 40% material weight reduction. And more importantly, as you get into dollars and cents, it's more economical, less steel. In addition to that, there's allows us to use smaller diameter rods, and again, more of the weight reduction. All of these have been fully tested to meet or exceed our performance requirements, so there's nothing lost as far as performance. That's more importantly, it's gained because of a material weight reduction and more cost effective. Here's a picture of the, as you can see in the bottom right, a picture of the housings. So you can just see the geometry is virtually the same as the RH. There are, to the naked eye, it may not appear that there's a difference, but put it side by side, you need to see a little bit of a difference. We'll get into that as we move on. Okay, so compact hygienic series. And if you remember back to the RH, it looks very similar to this, but you may just notice it's more streamlined. The exploded view of all the components, again, it still utilizes that same design on the shoulder bolt for the slope adjustment feature, O-ring seal on the top, having 2 polysulfone inserts, virtually the same design. However, in addition to the RH design, it is more compact, still as hygienic, same rounded type geometry. The strength actually exceeds what our design expectations are with the safety factor included. One thing that is gained is that it's a little bit easier to install, and I'll show you in just a moment. A very minor change to the design or an addition to the design, and allows a lot of, well, I guess, ease of installation, so there's less to be concerned about. BPE compliant, certainly. The ease of installation is really tied to the no loose parts principle. This particular graphic just mentions, that polysulfone insert has 100% contact on the circumference of the tube or pipe or copper tube, whatever diameter pipe that you're working with. So you're minimizing any areas of entrapment, also dampening vibration, and more importantly, it's a hygienic design where there won't be any external pooling of any product. The patented design, as I mentioned about that shoulder bolt hole on the housing, allows that slope adjustment in either direction from center. So as you may have different slope requirements, quarter inch, eighth inch per foot, this will accommodate any of those as they're dictated by designers. And also, as I mentioned, it meets requirements of the ASME BPE standard. You may be seeing more and more of the call-outs for 88 and 92 degree elbows and T's. Our particular slope adjustment design facilitates that, so there's not any additional stresses put into the pipeline as they're starting to incorporate slope. This covers the same point. Sorry. Side by side, the RH and the CH. You might not notice much difference, and there truly isn't from this angle. Frankly, just a few design features, differences between the RH and the CH. You'll see more in particular in the next few slides. The design of the CH, again, it's the width drops by about a quarter inch on groups 1 through 5. Has a smaller diameter rod on many of the dynamic and threaded housings. There may be a slight centerline difference from the current RH due to smaller dimensional envelope, and again, it's a fairly minor change to that. The other change was on our CHW, which is a weld plate style. The weld plate itself has been reduced in size to allow the installer to weld that plate in less time. There's less surface area to weld. And the one more important thing is at the bottom, all sizes now have a retention O-ring to capture the Acorn bolt, i.e. no more loose parts. One thing that I'm sure you may have heard from installers or pipers over the years is they lose things. The whole point here is everything is all going to be self-contained, configured, and assembled to ready to be installed. So that's again one of the key points. This particular slide, you can see the difference. The width drops down. Then now this is the threaded housing, so you can also see that the diameter of that thread on the top of the housing drops down also. Other nice feature as the threaded rod is assembled, it's profiled to virtually match the diameter of the threaded rod and give it more of a slimline, streamlined look. You may be asking, well, what's going to happen with the RH? Well, we're simply going to be taking a transition approach, so we're going to phase in the CH and phase out the RH. The CH, again, as I mentioned, should be launched within, hopefully, the next month or so. We have several of the housings and inserts in stock. We are just finalizing that process right now and verifying everything is ready to go. The one point to make is that the components between the two, for simple reasons of that there's different widths and different dimensions, are not going to be interchangeable between the RH and CH. So that's something to really be cognizant of. The inventory on the RH is going to be supported for a couple of years, including the spare inserts. So if down the road people want to have an RH style versus the CH, and again we will have these here for a couple of years. However, I think that one thing, especially in the groups 1 through 5, more often than not, people are going to be very concerned about pricing. So, being that the CH is going to be more cost effective, I think that it'll be a natural fit to use that for those applications. And in many cases, we found that if you take a smooth bore block and have a hang plate on the top, which is a common installation configuration, that the CH version actually would be more economical. Again, that's only in certain size ranges, but this is good news. And again, what I want to point out was the no loose parts. We would, as you configure the part numbers, we basically build to order, pre-assembled. So all you need to do is simply take it out of the box, and it can go right into the installer as is, without any loose parts to worry about or actually to lose. Here's a couple pictures. Actually, I got a few slides here to show what that looks like. The first one on the left here, you can see the hole on the insert where the bolt hole goes through has been opened up, and simply a small red silicone O-ring and installed in there allows that Acorn bolt to stay captive to the housing. So we open up the diameter of that insert hole, and you can see on the next few slides here how that all kind of goes together. So the good news is that versus other options out there, from a competitive standpoint, ours is simple and easy and self-contained, whereas other particular designs would require a lot of additional assembly on site. And again, more user-friendly is what we're trying to go for. And again, more point of views for that. The size range that we have is, as I mentioned, we have these things identified by group, and again, for the same purpose of consolidating hardware, we have 9 hardware groups that encase inserts that range through 27 sizes in all. I'll have a graphic that'll show that up in the next few here to show the size range. But it's 304 stainless steel, 316L is an option for the housing, as well as all the rods. 25 RA is the standard finish. Here is what the housing groups sizes all contain. So example, for group number 5, you can see it has essentially 3 sizes: 1.5-inch copper tube, 1.5-inch pipe size, or 2-inch stainless tube. So that 2-inch diameter is typically the default that we have as far as the optimal design feature. So you have the housing really in proportion to optimizing that tube size insert. As you look at that, it goes from 1.625 through 2 inch, so the insert itself is a little bit thicker to fill in the gap. So you'll see from that perspective, it's allows several sizes of inserts to fit in within the same housing. These are the dynamic housings. Just showing a visual of that. Next slide here shows the threaded housings, and to point out the threaded collar on the top is more streamlined in look. The thermal expansion guide. Essentially, the inserts are 2 options for any one of these sizes: tube, copper tube, or pipe. You have an anchor or you have a guide. The anchor grips the pipe and holds it in place. The guide allows thermal expansion and allows that pipe to slip through. The mounting configurations that we have. This is just a quick visual to show the 4 primary options we have. Certainly there's customizable options available. They are called a dynamic or a slope adjusting configuration. And then we have 3 rigid, one with a welded bar, one threaded, and one with a weld plate. First one we'll go into is our I guess, flagship, the dynamic slope adjusting. This is the particular design that allows the drainability, slope adjustment, and has all the primary design features that pharmaceutical design requires. So again, it allows that for self-adjusting on the slope to create drainability. Typically, it comes with a 6-inch length rod. And one thing I wanted to point out on the top left, we show figure 121 RH, and in our new catalog you'll see the CH. Essentially, we just changed the prefix from a 1 to a 2 for simplicity, ease of identification, and so the RH, also if you just refer to it as an RH, we would know that that's the dynamic version, as well as if you used a CH. Here is a quick drawing of what it looks like. We have actually, if you look in the drawing in the center, you see that dimension L as a minimum length. The reason for that is we have that shoulder bolt that extends up into the rod, and that minimum dimension gives it enough structural strength so that it doesn't cut into that bolt and compromise any of the strength of actually holding, supporting any of the weight that typically you'll have. And for that reason, we have a sticker actually on. As I mentioned, the 6-inch rod is standard, and people can cut that to length as needed. However, we do have a sticker that says "Do not cut below this line," and that'll simply give you a guideline of how far they can cut back. We also have a shorter version that is the absolute minimum that essentially is cut to that length near that that line as well. This just simply shows the graphic having a anchor on the left and a guide insert on the right. So it's the same kind of color coding that we had for RH. Black is your anchor, gray is your guide. This again goes for pipe as well as tube sizes, so you'll be able to easily identify where there's guides that have been installed. Next version is the rigid. Has a welded bar. It's ideal for supporting a vertical run and reducing vibrations. Any of the rigid, the 3 options we have here do not have the dynamic slope adjustment feature in there. And again, this is depending on the particular orientation of that piping, it may be better to use a rigid design. But certainly, if drainability in a horizontal run is critical, we certainly recommend using the slope adjustment, our primary product. This simply shows that we have a rod welded directly to the housing versus having that shoulder bolt and swivel feature. Again, same scenario. We show the guide and the anchor. The other option here with rigid is a threaded design. This is a very popular design because it allows having a separate rod that can be cut to length, and again, typically not used in horizontal long length piping because it's not slope adjustment. However, it is versatile. The rods, again, has a threaded end on it. These are all sold separately to length, so those are made to order. The housings, again, are just the housing itself, and you would assemble the rod at the time that you're installing. And as you can see on this particular design, that figure 245, the rod, as it threads into the housing, it's profiled so that the diameter of the rod and the diameter of that threaded coupler on the housing virtually identical in diameter, so more of a streamlined look. And again, this just shows just the general orientation of that housing. Also, same scenario with anchors and guides. This is repeat. Now I have several pictures which may help just to put it in perspective. This particular unit, which is adjacent to that ball valve, is the the RHT Threaded housing. And you can see that's has a small section of rod welded right to a support structure. Same scenario here for an RHT. Several pictures here of a dynamic mount. A lot of these here are assembled on a skid assembly. So you can see a lot of these all kind of mounted in different orientations. This one here actually serves as a spacer between two vertical lines. And here, here we have one at the lower end of a vertical bend. Also, you can see that is quite short of a rod extension, but it allows that slope adjustment. We also find some interesting, some new opportunities. This one here doesn't necessarily clamp around piping. It actually has an instrumentation. I think that's a Rosemont gauge or something like that. It simply serves as a brace or a holder to use for the instrumentation, and it is a very streamlined look. And we've had some really positive response on using these. It seems as if there's more and more applications that are evolving that a lot of skid builders really find very useful. This just shows the skid prior to any of the piping installed, so that you can see that the dynamic housings are all mounted in different orientations. And what's nice about it is it is very streamlined in look. And once it's all installed, gives it a nice a nice visual. Well, certainly it's nice for me to see a lot of our product installed, but what the important thing is to take away from this is different orientations of that piping. And also to point out that it also allows to have these in a very tight location, such as this, and be able to get in and if something needs to be adjusted down the road, a very simple adjustment feature to get in, open that up, and make any kind of adjustments. And again, more of the same. I think we're just about done with pictures here. The next few pictures I'm going to show here have the smooth bore series. I think it's important to show applications where that is also used. This particular version here is a strut mount. As you can see on the back of this, or the bottom of the housing itself, that is strung through a strut, which is a channel, and that's maybe a little bit difficult to make out, but there's actually we have a strut nut that is designed specifically for mounting in struts. It allows, in lieu of using a weld plate, there's the strut nut that rotates 90 degrees, so you can fit it through the channel, rotate it 90 degrees, and then tighten up from there. And it's a very simple feature for that to be used in strut. Now again, this is a hygienic. This is actually on a test rig, testing some products, valve cycling, and more for hygienic process, but the environment is not a washdown environment. Here's a version showing the weld mount. So you actually see that has a cover plate. At the bottom is a weld plate, and then there's, I believe that's 1.5 or 1 inch square stainless tube that is mounted right or welded directly to that weld plate on the bottom. Here's a better view of that strut mounted series. So as you can see, there's several assemblies in tandem, all basically confirming valve cycling times or some of the process performance of any of the process components. But you can see that there's a long strut channel that has all these mounted on there, and they're very quick and easy to mount as well as to move if necessary. We have one other picture here showing underneath a process vessel, a pharmaceutical process vessel. This is on a skid that has used the smooth bore. Is also very common. Really depends on the design requirements, if this is going to be required to be washed down, or if it needs to be insulated somehow. Really up to the designer, but it is very common to use a smooth bore with the Sanitary, which handles the higher temperature. One other picture using the strut mount. As you can see, there's a few valve bodies directly above those. The important thing is that to know is that there's a very the gripping force again will hold against the shear force of the weight, and if there's any thermal expansion or any water hammer, that it'll dampen that vibration through that Sanitary material. The last configuration that we show is a rigid with a weld plate. Here's a side view. Essentially, it's taking that housing and has a small weld plate. The one thing I pointed out, this is very popular with skid builders because it's very streamlined, very versatile and small, so it allows them to fit within that framework that they're building the skid on, and not a lot of extra componentry required. You can see that weld plate. I don't know if you've had seen any of the prior versions with the RH. We essentially reduced that diameter in the, I think groups 1 through 5 have about a 1.5 inch square weld plate versus what it was prior, which was more rectangular and did take a lot more time to perform that seal weld around the perimeter. And again, side-by-side anchors and guides. The other thing to point out about all of the inserts, I forgot to mention earlier, actually molded into the insert is going to be the size and a T for T for tube, a P for pipe, and a C for copper. The copper inserts are all going to be pre-molded, so all your inserts you wouldn't have to have. Typically for copper, we were boring out from blanks, made to order type scenario, and now they're all going to be dedicated and pre-molded. So there shouldn't be any waiting time for your order. And again, we're going to have the size actually molded into there, so for ease of identification. One more thing to point out here is Fabrications. This is again a very important feature for installation. These fabrications need to be done in many cases, whether or not it's done and performed by us in a factory environment or done out in the field and stick build to order. It's really yet to be determined, but we certainly feel that doing this in our facility may be a more cost-effective method versus doing it on site in a factory situation with where we can do a factory weld and a polish to clean up and make a uniform finish. And again, more of a time savings. Here's a couple examples using the block series. This allows a sub-assembly that essentially can be just reduce the amount of time that field welding is required, and so it can be basically built in as a modular system. Here's a floor stand with our RH mounted in there. And again, this is to facilitate quicker installation time in the field. Features of our stanchions. I guess the prime feature is the fact that it reduces the amount of time that it takes to install. Typically is one field weld that's performed to mount that stanchion onto either the support from above or support or on the floor, and then you would field weld the rod. You would orient the direction and elevation, and tack weld that in place, verify your slope, and then perform your seal weld after that. As a drawing of what the floor mount is, as I mentioned, you do your first field weld with welding the stanchion to the base, and then perform the weld of the rod of the hanger into the cap. Same scenario from the ceiling. I have 4 options as far as our standard stanchions. The figure 225 is our hang mount. These you have an option of 1.5, 2 inch, or 3 inch pipe, either square tube or iron pipe, and they have caps welded on there with holes suited to whatever rod diameter that you're going to be using, depending on the group size. Same scenario on figure 226 with the floor mount. Has a base plate with or without holes, different sizes of base plates suited to fit your needs. In addition to those, we have a figure 223, which is a base stand, typically for smaller group diameters, allows a more compact feature for that. The other one is a figure 224, which actually takes the RHR or CHR, the rigid version of our hanger, and it's actually welded to that base plate at whatever height that is required. And so simply it's bolted onto the floor, and again makes it a quick and simple installation. Here's a few pictures of fabrications. If you look on the right, you can see several floor stands. Those in particular are epoxy painted carbon steel in a non-clean room area. The other benefit that we'll get into on the stanchions has to do with the packaging and labeling. We have had requests, and we've been able to help facilitate the installation of many of these by identifying these with isometric labels. So the pipers have the ISO drawing with everything pre-identified, and we would have our stanchions, which in many cases, if it's a floor stand, you'll have a base plate that's separate from the stanchion that has the third component, which is the hanger with rod. Each one of those being labeled as 1 of 3, 2 of 3, and 3 of 3, and the isometric drawing number. We've used a special label that can be easily removed, so there won't be a lot of any adhesive if they want to, the installer needs that for identification upon installation, and then can be removed after that to create a clean look. And again, it's about a value add for the installation process. So here's an example of some base plates, also the rods on the right. And again, some more pictures of that, and also as it's installed. A little bit on the drawings and technical. Drawings of all of our hangers and stanchions available in the PDF, DWG, in the 3D step. In addition to that, we can do SolidWorks. Really depends on what the requirements are. So please let us know, when we will we'll provide as needed. We also do finite element analysis, as well as product data sheets as far as the from the polysulfone material. Ordering information, we have in our our catalog, the new catalog that's coming out within the next few weeks. Part number configurator, which makes it easy to configure our part. And again, it's same type of methodology as we currently have for the RH, but this, as you can see, the CH is the prefix on this. Our smooth bore, we have a prefix for the mounting configuration. Then we have a hardware material, group size for the housing, the tube or pipe diameter, and then the insert material. So very similar in configuration. The other thing to note is pipe weights. This is just a reference. If you take a 10-foot section of pipe flooded with water and insulated, as you can see on the right column, that is what that weight per 10-foot section, which in many cases might be the spacing of hangers between, holds 14 pounds all the way to 345 pounds. Our hangers certainly test far above that. I know we're getting tight on time here. We have a little bit here on spacing. This is our recommendations for spacing for every size and tube, copper tube, and pipe diameter, what the maximum spacing between horizontal sections. And one last thing is the product testing. We've done load tests, which it withstands the weight or impact from a vertical load, and from a shear test to ensure that that grips and prevents that pipe from moving within the housing, so it keeps it stable. I'm hitting our limit here on time, so I'll stop here, and hopefully what you take away is you've got a perspective of the scope of the product offering that we have, and I certainly appreciate your time and look forward to our next opportunity to handle any of your needs. If there's questions, certainly please feel free to send them in or contact Sean or myself at any time. My direct email is danm@behringersystems.com, and so I certainly appreciate your time, and hopefully we'll hear from you in the future. Thank you.
I just want to mention quickly, and that's I just want to direct everyone's attention to our website. We from our homepage on our website, which you should see in a second here, we have a button here on the left, or also on the top right here, that mentions online training. And if you click on that, you'll see any upcoming webinars that we're scheduling. Right now we only have today's listed. And the next coming week we'll list about 5 or 6 more that we plan on doing, more in-depth detailed webinars or advanced training courses, if you would, on each of our individual products. And then on the top you can see a little camera button, and if you click on that, it'll bring you to a list of our pre-recorded webinars. So after today, this webinar will be listed on here at the bottom after all of our pre-recorded webinars, and here you can see all the ones that we've already done. So we'll add it to that list. You can launch it in a Windows Media Player, or you can right-click it and download it and save it if you want to watch it at a later time, or if someone that you know has missed the presentation, or any of your customers you feel might benefit from it. So with that being said, we'll conclude today's webinar. And once again, thanks everyone for joining.
All right, have a great day.